Okay, kind of a refresher over what you've talked about the last 2 days for review. We want to look at this picture. We have a 45 to 45 degree angle. Try the problem before I go over it. Make sure you understand. Make sure you get correct. So, 45 degrees, that means this angle is also 45 degrees. My two legs have been equal. So that means that side Y will be 8 radical 2, which is approximately 11.3. In order to find x, because it's my hypotenuse, the hypotenuse is equal to the leg multiplied by radical 2. So it's 8 radical 2 multiplied by radical 2, or 8 times 2, which is 16. All right, is a triangle with side lengths 3, 4, and 6 right, acute, or obtuse? So this goes back a little bit, trying to remember with this. You do use Pythagorean theorem, so we want to use 3 squared plus 4 squared, and I'm checking to see how it relates to 6 squared. It's always small plus small equals the large values squared. So I have 9 plus 16 and 36, and 9 plus 16 is 25. So when I look at that relationship, I know that 36 is larger than 25. So if it's larger for the c squared, that does mean I have an obtuse triangle. Make sure you have that chart memorized from section 8.1 and 8.2. All right, so for today's notes, we are actually going to get into a little bit of trig today. So trigonometry to find missing sides. So we're just looking at sides. You can use sine, cosine, and tangents to determine the side lengths in a right triangle. We're using different ratios. So we want to understand opposite, adjacent, hypotenuse. And then we're using sine, cosine, and tangent. All right, so some abbreviations. When you see the word S-I-N, it is read as sine. Please do not say sin. If you see C-O-S, it's read as cosine, not cos. And tan is read as tangent, or tangent. So make sure that you say the entire word, not the abbreviation. So we want to talk about where the different sides and parts are located. It's very important to know which one is opposite, which one is your adjacent, which one is your hypotenuse. So to find opposite, it's always going to be the side that's across from the angle. So if you have to go through the middle of the picture from the angle to the side, that is your opposite. This symbol that we have in here, it's actually it's a Greek word. We use it a lot in the trigonometry class. The word is pronounced theta. It's a reference angle. All right, adjacent. So adjacent is actually going to be a side of the angle itself. So it's a side that touches the angle. It's one of the sides of the angle, but it's not the hypotenuse side. The hypotenuse side itself is the side opposite the right angle. The corner of the right angle, so if you make the right angle, the corner of it actually points to the hypotenuse. It's always also going to be the longest side of your triangle. All right, so decide which function you're going to use, sine, cosine, or tangent. It's based upon what you know. We are using what's called SOHCAHTOA, is the little acronym that we use. So the idea with SOHCAHTOA, so if you look at what I had up above, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So we're looking at those values. Now I've given you a chart here that has those on it as well. We're going to finish filling this in. So sine of angle A. Angle A is here. So the first thing I might want to do when I'm deciding on this is to label my sides. So my opposite would be the one going through the middle. The adjacent is a side of the angle, but not the hypotenuse. And the hypotenuse is always the longest side. When I want cosine, cosine is the leg adjacent. So looking at my picture, that's B, and that hypotenuse is C. And if I want tangent of angle A, that's the opposite, which is my A, over the adjacent, which is my B. And those ratios, you always want to make sure you reduce and simplify to lowest terms. All right, so what are the sine, cosine, and tangent ratios for angle T? So again, I want to label this. So I have my opposite is the one that goes to the middle, the adjacent is attached, and the hypotenuse is the one opposite of the right angle. So my sine is opposite over hypotenuse, so it's going to be 8 over 17. My cosine is adjacent over hypotenuse, so it's 15 over 17. And my tangent is opposite over adjacent, which is 18 over 15. Now I want to check those numbers. And if they can be reduced, they should be reduced. And that should be an 8, not an 18 on that last one. And so 8 over 15 does not reduce, so we are good on those. But if it can be reduced, you should look at reducing them. All right, so what are the write the ratios for sine, cosine, and tangent for these three shapes? So make sure you're paying attention to what angle. So angle x this time is up at the top. So my sides, I'm going to go ahead and label them opposite, adjacent, and hypotenuse. Opposite is be on the bottom this time. Sine is opposite over hypotenuse, so it's 12 over 13. Cosine is adjacent over hypotenuse, so it's 5 over 13. Tangent is opposite over adjacent, so it's 12 over 5. Looking at the next shape, I'm looking for angle x this time again. So my opposite will be on the top, or the side. My adjacent will be on the bottom. Sine is opposite over hypotenuse, so I have 8 over 16. That can be reduced to 1 over 2. You can leave it as 8 over 16. Higher level classes, you're definitely going to want to reduce that. But because it says just write the ratio, you're okay with leaving it. All right, cosine is adjacent over hypotenuse, so it's 8 square root of 3 over 16. And my tangent opposite over adjacent is 8 over 8 square root of 3. Now those are not best answers, but because they are just the ratios, we can keep them that way. Problem number 3, angle x up here at the top. So I have my opposite down here at the bottom, my adjacent, and my hypotenuse. So sine opposite over hypotenuse, 4 squared root of 5 over 12. Cosine is adjacent over hypotenuse, 8 over 12. And tangent is opposite over adjacent, so it's going to be 4 squared root of 5 over my 8. Create trig ratios and solve for x. So I've kind of given you a little bit of a how to do this on the paper. So which sides do you know? So we're actually going to solve for these problems. So here's my angle, and if I label my sides, I have my opposite, my adjacent, and my hypotenuse. So which sides do I know? I know my opposite is x, and my hypotenuse is 9. So using opposite and hypotenuse, which of my trig functions is that? So that's O and H. Well, O and H is sine. So that would be my sine function. And so my equation for this will be the sine of my angle, which is 32 degrees in this case, my length of my opposite, which is x, and then my hypotenuse, which is 9. All right. So I want to solve this. So if you think about it as a proportion is over 1, I'm going to cross multiply. Or you can think about it as having to get rid of that fraction. So I'm going to multiply both sides by 9. So I have 9 sine of 32 degrees equal to x. Now on your calculator, you're going to type this into your calculator. You want to make sure that the mode of the calculator is degrees. If you have a graphing calculator, TI-83 or 84, you want to hit the mode key, which is on the top left corner. Go down to where it says degrees and radians and make sure the degrees is highlighted. Hit enter and then clear to get out of that. If you have a red calculator, you're looking for the key that says DRG. DRG. If your calculator does not say DEG on the screen, then you're going to go to the DRG key, press it, make sure you highlight the DEG, and then hit enter. All right, so how do you know your calculator's in the right mode? When you type this in, you should get 4.8. If you don't, then you want to go back and make sure that the calculator is in the degree mode. All right, problem number 5. For this one, I have my angles up at the top, so my opposite, my adjacent, my hypotenuse. So which ones do I know? I know opposite is x, my adjacent is 25, I don't know the hypotenuse. So of these, which one do you think it's going to be? So I have O and I have A. Well, O and A is cosine. So cosine is, sorry, that's incorrect. O and A is tangent, so it's TOA, and so that means I'm going to be using the tangent function. To write your equation and solve, so it's going to be tangent of my angle is 15 degrees, equals opposite over adjacent. Opposite is x, adjacent is 25. Please make sure you watch the Getting Tricky with It video that I'm going to post. So it kind of explains this in a little bit different manner for you. So kind of fun way to look at it. So this one is a multiply because the x is on the top side. And so typing that into your calculator, you're going to get x is equal to 6.7. You are going to go to 1 decimal place. All right, problem number 6, which is off on the side on your paper. Filling in space here. My angle is up here at the top, so my opposite is going to be on the right side, my adjacent, my hypotenuse. So what do I know? I know my adjacent is x and my hypotenuse is 4. So that's A and H. So if I have A and H, that's going to be my CA, so CA, TOA. So that one's going to be my cosine. So my function is going to be cosine of my angle, which is 73 degrees, equals adjacent over hypotenuse, so x over 4. All right, so this one is like the previous. You're going to multiply by the 4 to get the x by itself. Typing that into the calculator, rounding to 1 decimal place. So it started off as 1.169. That's 6, and going to round that 1 up to a 2. All right, so 1.2 is our answer on that problem. All right, number 7, next page. Create your trig ratios and solve for x. So same as the last problems, but I haven't given you all of the information down below, so you have to think about it a little bit. There's my angle, my opposite, adjacent, hypotenuse. So I know opposite is x, hypotenuse is 15. That's O and H. So which one is O and H? That's sine. Sine is opposite over hypotenuse. So I will have sine of my angle, 20 degrees, equals opposite over hypotenuse. And so that will be 15. Sine of 20 is equal to x. Again, you're typing that into the calculator, and x will be equal to 5.1. All right, next picture. OAH. So I know I have, if I do OAH, I don't know my opposite. My adjacent is 6. My hypotenuse is x. A and H, that's CA, so CA TOA. So that's going to be cosine. So I'll have cosine of 33 degrees equals adjacent over hypotenuse. Now this is the first one we've had where the x is on the bottom of that fraction. So you have to do something a little bit different here. You're going to have to exchange these two numbers. All right, if x is on the down low, you divide, you know. That comes from the video. So it becomes x equals 6 over cosine of 33 degrees. And that's going to equal my x value of 7.2. Again, watch the rounding. It was 7.15. That's going to round it up to a 2. Problem number 9. We have our angle, so opposite, adjacent, hypotenuse. So if I do my OAH, my opposite is 9, my adjacent is x. Don't know my hypotenuse, so what uses OA? That's going to be tangent for SOHCAHTOA. So tangent of my angle of 55 degrees equals opposite over adjacent. Again, that x is on the bottom, so we're going to switch the two positions of these two values because they would be the cross multiply on my proportions, and I would have x equals 9 divided by tangent of 55 degrees. So x will equal 6.3. All right, we have a couple more problems left to go, but I'm out of time on this video, so I will add one more video to this to be able to finish this lesson.